everybody. In this brief video, let's take a look at sampling distribution of sample means. So I'm going to fully go through an example here. I've already kind of started it to speed us along, showing all the important pieces of one of these examples. So let's get to it. The average weight of a grizzly or of grizzly bears is 600 pounds with a standard deviation of 60 pounds. Park rangers are going to randomly select 40 grizzly bears and record their weights. What is the probability that this, sample mean weight of grizzly bears is less than 580 pounds? Okay, let me say that one more time. What is the probability that the sample mean weight of grizzly bears is less than 580 pounds? So, things that I would do is first just pull out what information is in the problem in the first place and what does it mean. So, it says the average weight of grizzly bears. This is of all grizzly bears. The average weight is 600 pounds. So that is a population mean. So I'm going to put mu is 600, okay? And followed right behind it is with a standard deviation of 60 pounds. So standard deviation, 60. So my population of grizzly bears has a mean weight of 600 pounds, standard deviation of 60 pounds, okay? That's going to be important. Park rangers are going to randomly select 40 grizzly bears. So they're going to go out, hopefully randomly select 40 different grizzly bears from all over, and we're going to record their weights. So that 40 is actually my sample size. I'm going to go out and collect a sample of 40 grizzly bears. Then we want to know what's the probability that the sample mean. So basically, if I take those 40 bears, record all their weights, and find their average weight, so that's a sample mean, what is the probability that the sample mean weight of grizzly bears is less than 580 pounds? So our sample mean is 580. X bar is 580. And we'll see how this is all used here in a second. So in order to do this problem, we go from a population, we're talking about, hey, how does our sample, how does it compare? So it's a sampling distribution problem because we're seeing how does my sample mean kind of compare and what's the probability that my sample mean is below 580. So it's a sampling distribution of sample means problem. So in order to do that, we need to jump into our conditions. So I already wrote those out for us. The three conditions for a sample mean problem is you need to check independence 10% and n is greater than or equal to 30. To check independence, what we hope to see is that our sample was randomly selected. So if we went and looked back up at the above problem, it did mention that the sample of 40 was randomly selected. 10% condition. That's making sure things are not too big. Our sample is not too big. It's helping us with independence here. So what we want to make sure is my sample of 40 is not more than 10% of the population of all grizzly bears. So I'm hoping there's more than 400 grizzly bears. That would mean, yes, my sample of 40 is less than 10% of the population. So that's helping with the independence. And then finally, we need to make sure my sample is large enough. We use n is greater than or equal to 30, so I hope my sample is at least 30. We have a sample size of 40, so that means it's big enough, okay? Because of all three of these conditions are met, that means our sampling distribution of sample means is approximately normal, okay? Because we went through these conditions, I now know my sampling distribution of sample means is approximately normal. That means we have that nice bell curve. So what we can do is we can find the center of my sampling distribution and the standard deviation of my sampling distribution, and it's going to allow us to do a whole bunch of things. So we had talked about mu of x bar, so the center of my sampling distribution is just mu. So the center of my sampling distribution is just 600. So I could label, hey, the center of my sampling distribution is 600. The standard deviation of my sampling distribution of sample means is just the population standard deviation divided by the square root of the sample size. The population standard deviation is 60. My sample size is 40. So we're talking 60 over the square root of 40, which I did that in a calculator off screen already. It is 9.48 when you round it there. So I know my sampling distribution is centered at 600, and it has a standard deviation of 9.48. Okay. From here, once you have a sampling distribution that is approximately normal, we can race off to z-scores, get a probability, and get our answer. So let's start with a z-score. In order to do it, we're going to need to know what our cutoff point is. That's where that x bar of 580 is. We wanted to know what's the probability that my sample mean weight of grizzly bears is less than 580 pounds. So if 600 is in the center, 580 would be right around here. And we want to know the probability that is less than 580. So we're talking about the area to the left. So doing a z-score here, we're doing 580 minus 600 divided by 9.48. I got that all from my sampling distribution. I did this calculation, rounded it for us off screen. It's negative 2.11. So we're almost done here. Once you have your z-score, you're going to go to your z-score table, and we need to look up our z-score of negative 2.11 and see what proportion of z-scores is less than this point. So the proportion of z-scores that are less than or equal to negative 2.11. Be careful with your z-score table. Remember, it only gives you the area to the left, so we don't need to do anything fancy here. When you look up negative 2.11 on your z-score table, you're going to get 0.0174. Final thing we need to do here, context. Explain what in the world does this mean? Okay, so we're going to change this over to a probability. From a proportion to a probability, that is a 1.74% chance the sample mean, or the sample weight, of grizzly bears is less than 580 pounds. Okay, so what we found is, hey, if you're going to go out and get a sample of 40 grizzly bears and record the average weight of those 40 grizzly bears, there's a 1.74% chance that average weight will be less than 580 pounds. That was a quick run through of a sampling distribution of sample means problem.